Hey everyone, welcome to our next video. This one is 4.3. 4.3 is more equations, but this one is equations involving compositions. And so of course I'll explain what that means. Mostly what we're going to be working with in this section is if there's like other stuff in the parentheses. So if it's like sine of something equals a number, but let's say it's more than just a variable. Like we'll say maybe it's 2x or maybe it's x over 3 or just something like that. So we're looking at if there's other stuff besides just the variable inside of our parentheses. So of course, I'm just going to kind of start with an example. Um, this is actually really similar to 4.2. There's just maybe like one-ish extra step that we'll have to kind of take care of. And then towards the end of this section, I will also talk about when it's possibly going to be useful to introduce maybe an identity to help us with our equation. So we'll get there at the end. But for now, let's just deal with some of the more simple ones. So solve for all values of this one. I'm using alpha. And remember that your variable can be anything. So it could have been x, it could have been theta, it could be whatever. Now be careful as well when it says all values, that means we're going to have to be using the whole like k thing from 4.2. So make sure we keep that in mind. So sine, let's do 2 alpha is equal to square root of 2 over 2. And so the first step that I would take with this one, and this is just, kind of how I handle them. I like to replace what's in those parentheses with just another letter temporarily. So I'm going to say, let 2 alpha equal x. And so the reason that I'm doing that is I want to show you that we can actually turn this into a 4.2 problem, solve it that way, and then we'll just have an extra step at the end. So this will be sine x. So I'm just replacing 2 alpha with x. So I'm replacing that equals root 2 over 2. Now it just looks like a 4.2 problem. So when we're thinking about what angles would I plug into sine so that it equals root 2 over 2. So I can always go back to my table and stuff. Let me go ahead and draw those out. So sine, cosine, 30, 45, 60. Fix that 3. That 3 is kind of ugly. Okay. So sine is square root 2 over 2 at 45 degrees. So that means that this x has a reference of 45 degrees, but we should be careful here because we need to check out the quadrants. So it's positive here, so that means I'm thinking about where is sine positive. Well, sine is going to be positive in 1 and 2, and I'm looking at a reference of 45. So my angles here will be x equals 45 degrees plus 360k and 135 degrees plus 360k. we're not finished because we found x, but we don't want x, we want alpha. So I now need to plug in my 2 alpha like back in as x. So now I'm going to have 2 alpha equals 45 degrees plus 360k. 2 alpha equals 135 plus 360k. And I need to solve these for alpha. So we want to think, how do we solve for alpha in this case? We would divide by negative, I'm sorry, not negative, divide by 2. So we get alpha equals 45 divided by 2 is going to be 22.5. 360 divided by 2 is 180. 135 divided by 2 would be 67.5. And 360 would become 180. So this is actually my final answer. Now, because we ended up with that like 0.5 thing, I would say that this is actually a good example of maybe a time that using radians would have been a little bit nicer. Because then I would have had pi over 4 plus 2 pi k and 3 pi over 4 plus 2 pi k. I replace with 2 alpha. So over here, I'm just showing you what the work would look like if I had used radians. Now, if you divide by 2, remember that that's the same as as multiplying by a half. So you would end up with pi over 8 plus pi k and 3 pi over 8 plus pi k. So that is the answer in radians. And so thinking about the fact that you won't have a calculator, well, you can choose not to have a calculator. Test 2 is structured to be done with no calculator. So if you choose to do that, you may want to use radians for a question like this. Now, I'm not very picky about radians or not. Just be careful of what the question asks, you know. But in general, that's what we're going to do for all of them. We're just going to let those parentheses equal something else. That way we can treat it like a 4.2 problem, and then we'll just replace the parentheses at the end. So let's do another one. This one I'm actually going to not make us do all values of a variable. I'm going to restrict where we want our answers. So I'll make it a new example. I'll say solve let me write the equation first. I'm trying to, structure it a little better. Cosine alpha over 2 equals 1/2, where alpha is between 0 and 1000 degrees. Now, anytime they give you an interval like this, make sure you watch out for if it wants it equal to or like not equal to. Since these have it equal to, if we get 0 or 1000 as an answer, we'll want to include both. Sometimes you'll see it do something like this where they don't have it the equal to on one side. So that means that we would just put in one of those answers if we get them. So just be careful about that. Something to kind of pay attention to while you're working through these problems. So again, just like in the last one, I'm going to let my parentheses be something else. Just ignore it for a moment. So I'm going to let alpha over 2, let's just let it be x again. So now I have cosine of x equals a half. So I come back to my table. Let me go ahead and bring it down with me so that I can have it in the same area that I'm doing the problem. So I'm trying to figure out, okay, which angle do I plug into cosine to equal a half? So that's looking like 60 degrees. That means that my x has a reference of 60 degrees, but we need to watch out for the quadrant. It's a positive 1/2, so I want to think about where cosine is positive. Cosine is positive in 1 and 4. And so at least for this part, I really do think that you should pause and maybe try to do this problem yourself. So my references are 60. So my quadrant 1 answer will just be 60 degrees. Now here's the part that's a little different. You want to keep the plus 360k for now. So we're going to keep that on there, and you'll see why. And then my quadrant 4 answer would be 300 degrees plus 360k. Now, because that interval is in degrees, my answer is going to stay in degrees. If they had given me an interval in radians, I'd probably want my final answer in radians. Now, again, I'm not usually very picky about that kind of thing, but it is the correct way to do it. Is if they give you a degree, like if they kind of hint to you, hey, we probably want degrees, then you should probably stick to that. If they kind of hint in radians, they want your answer in radians as well. Okay, but we're not done because we need to replace that x, we need to put alpha over 2 back in. So I'm just putting that back in my problem. And now I need to solve for alpha. So in this case, that's going to be multiplying by 2. So let's see, I get alpha is equal to 60 times 2 would be 120 plus 360 times 2 would be 720. 300 times 2 would be 600. And then 360 times 2 is 720. And so I'm only going to deal with the interval at the end. So now I'm going to deal with it. So it says that I only want answers between 0 and 1,000. So 120 is an answer between 0 and 1,000. And then it also says that if I add 720 to that, I get another answer. So we would like to see, okay, is that going to be in my interval? So if I do 120 plus 720, that would give me 840. That's going to be in the interval, so I'm going to keep that answer. Now, if I add 720 again, I'm not going to be in the interval anymore, so that's going to be it. 600 was in the interval. 840 is in the interval. And then I also should check, what if I do 600 plus 720? Does that give me something in the interval? In this case, it does not, because 600 plus 720 would be 1,320, and that's too big, so that's not going to be included in the final answer. So let me just pause so you can kind of take this one in. I'm going to maybe recap a little bit. So first we let the inside of our parentheses be a different letter, just so we can make it more like a 4.2 problem. Then we did that. We treated it like 4.2 problem. We found what our new variable x needed to be. Then we plugged in my alpha over 2. We put it back in place. We solved for alpha. And then we had to only pick angles that were in the interval that we wanted, which was 0 to 1,000. So for instance, sometimes for this one, I'll get people to only find 120 and 600. Like they'll miss out on the 840 because they forgot to add in the 720K. That would be like a minus, it depends. It could be -2, it could be -1. It depends on where you showed work, right? So if you remembered to keep the 360 and then you wrote 720, but maybe you just actually forgot to add it in, that's probably only a -1. Now, if you forgot the 360 all the way up here, then you made an earlier mistake, so you'd probably lose a little bit more credit there. All right. Let's go ahead and just keep doing some more. So this one's going to be example 3. And this one says solve 2 sine x plus pi over 6 plus 1 equals 0. And this one says that x is between 0 and 2 pi. So that tells me I should probably be using radians. Also, the fact that this is in radians, I should probably stick to radians. Now, that's not going to be like a big deal for me, on a test, because I just happen to not be very picky about it. However, the best thing to do would be to stick to radians. So that is how I'm going to do this problem. I'm just going to stick to radians. So for this one, again, we'll let that be a different angle, like a different letter, variable. So let's say x plus pi over 6. I don't want to pick x because it's already there. So I don't want to pick something that's already written. I want to pick something new. So let's do, I don't know, just any letter really. Let's do B. It doesn't matter at all what you pick. So now I have 2 sine B plus 1 equals 0. I'm going to solve this. So I move that 1 over, and then I can divide by 2. So I'll get sine B is equal to -1 over 2. So where does sine equal 1/2? That's going to happen at 30 degrees. So that's just my reference. That doesn't necessarily mean that B will be 30, but it'll have a reference of 30. Or in this case, since I'm trying to stick to radians, I can write that as pi over 6. But now we have to also consider the fact that it's a -1 over 2. So sine is going to be negative in what quadrants? You think about it. It would be 3 and 4. So I have a reference of pi over 6 and I'm looking in quadrants 3 and quadrants 4. So remember that this is pi, which can be written as 6 pi over 6. This is 0 or 2 pi, which could be written as 12 pi over 6. 6 pi over 6 plus pi over 6 would be 7 pi over 6. 12 pi over 6 minus pi over 6 would be 11 pi over 6. So my answers here, I'm getting B is equal to 7 pi over 6 plus, don't forget the 360k, which in this case would be 2 pi k, because we're in radians, and 11 pi over 6 plus 2 pi k. Now I'm going to go ahead and substitute this back in. So I have x plus pi over 6 equals 7 pi over 6 plus 2 pi k. On the other side, x plus pi over 6 is equal to 11 pi over 6 plus 2 pi k. Solving for x, I can subtract pi over 6 from both sides. For my first one, 7 pi over 6 minus pi over 6 would be 6 pi over 6. And that one can actually reduce to just pi. And then on the other side, I get 10 pi over 6, which could also reduce into 5 pi over 3. But we want to remember that we only want answers between 0 and 2 pi. So those are the only answers that I'm going to keep, is if it's between 0 and 2 pi. So pi works, 5 pi over 3 works. If I add 2 pi to pi, I'm no longer between 0 and 2 pi. So for this one, my answers will just be pi and 5 pi over 3. And that's just because if I do add the 2 pi k, like if I tried to add it, I'm no longer in the interval, so I don't want to do that. Just be careful there because every problem is different. So for instance, for this one, you may have thought, okay, why did we need to put the 2 pi k anyway? It's because sometimes you'll need it. For instance, with example 2, we needed to include the 360k because it changed to 720 and it actually ended up giving us another answer than we originally got, which is the 120 and 600. So you want to always keep the plus 360k or plus 180k, whatever it is, just in case you need it. However, you will find that sometimes you won't need it. Like not that you didn't need it, it just maybe it didn't result to anything, but that's okay. Let's look at example 4. This one says solve secant alpha over 3 equals 2, where alpha is between 0 and 360 degrees. So this is one that we're going to be using degrees. So again, I always like to start with changing this part. So I like to just say right off the bat, if I see that, I'm just letting it be something else. In this case, we can use x since it's not already written there. So now I have secant x is equal to 2. Now I did a problem similar to this in 4.2. I said that we can just think about the reciprocal function and then flip the other side. So remember that if something does not have a denominator, that denominator is just 1. So I can change this to cosine because cosine is the reciprocal of secant, and then I can just flip the other side. So try not to overthink it whenever you run into a reciprocal. If it was cosecant, we would have flipped and turned it to sine. If it was cotangent, we'd have changed it to tangent. But we're flipping what's on the outside. It's not like I didn't change at all what's like in the parentheses, so be mindful of that. So now I'm just going to treat this like normal. So cosine is equal to a half. It's positive, so I'm going to be thinking about where cosine is positive, which is going to happen in 1 and 4. My reference here, cosine is 1/2 at 60 degrees. So for my x values here, I get 60 degrees plus 360k, and I get 300 degrees plus 360k. I need to replace the x. Solve for alpha. So this is going to give me 60 times 3, which would be 180, plus 360 times 3 is 1080. The other side, I get 900 plus 1080k. But we'll be careful because I only want answers between 0 and 360, and the only one I see here that can give me that is 180. So my answer to this is just 180 degrees. Sorry, I didn't mean to write the K there. All right. I want to show you something else that I do see pretty commonly. So let's take a look at something like this. Let's say example 5. We'll say solve for, let's do all values of alpha. And I just want to show you like some different things that I've seen people do. So let's work with this one. Cosine two alpha is equal to negative, let's just do 1/2. I don't know, something like this. sometimes I've seen people do this. So cosine 2 alpha, if you look at the identity sheet that I have posted on our Canvas, there are identities for cosine 2 alpha. So sometimes what I will see students do is try to use one of those identities instead of doing it the way that I've already shown. Sometimes this can actually work, and sometimes it doesn't. So I would be very, very careful about doing that. I want to show you what I mean. So there's three options for the cosine double angle identity. So these identities here are written for you on your, oh, I didn't mean to write sign, are written for you on your identity sheet. Well, they say 2A on them. There's this one, 1 minus 2 sine squared A, and then there's also 2 cosine squared A minus 1. Technically, you could use one of these identities. I want to warn you about it. This one, you can't use. The reason is because, and I'll see people do this sometimes, they'll do this. Cosine squared alpha minus sine squared alpha. You might just want to watch for a second and not actually write this down. The issue is that there's no way that I can get this to become like one trig function by itself. It's just really, it's a lot harder to do it this way. So I would say this is a very bad idea. I've seen people do it this way. So they just replace this side of it. Again, I think you're making more work for yourself because when you try to solve this, you're going to have to subtract the 1 from both sides, then you'll have to divide by the -2. Then at some point, you're going to have to square root, which is a whole nother thing to work with. So, yeah, I'm just going to tell you, please don't do it this way. Please do not do it this way. There are times where maybe using identities will be useful with an equation. If the parentheses is your only issue, like it's one trig function, but there's something in the parentheses, that's not really a reason to try to use one of these identities because it doesn't actually make it any easier to work with. So I would like to tell you, please do not use an identity when you don't need to. If you have a singular trig function and there's just something else in the parentheses, it's best to do it the way that I've shown. So 2 alpha, the way I'll go ahead and do this one. So 2 alpha would equal x. I'd replace cosine equals a half at a reference of 60 degrees. But cosine is negative in 2 and 3. So I'm looking at a reference of 60 in quadrants 2 and 3. So this is going to give me 120 degrees plus 360k and 240 degrees plus 360k. I'm getting that because this is 180, so I'm either subtracting 60 or adding 60. Then I can replace the 2 alpha back in. Divide by 2. So then I have 120 divided by 2. That's going to give me 60 plus 180k. And then 240 divided by 2 is going to give me 120. And then I have plus 180k. So this is my final answer for this one. And it said for all values, so that's why I left the k in there. If it had given me a certain interval, then I would want to actually find the values in that interval. And so I can show you for that. So if it had said for, let's say, alpha between 0 and 360. If that had been the case for this question, 60 would have been an answer. 120 would have been an answer. If I add 180 to 60, do I still get an appropriate answer, like between my interval? The answer is yes, I do. So for this one, I would want to do 60 plus 180, which is going to give me 240. I can do, let's see, what if I do 120 plus 180? Do I get an answer out of that? That's going to give me 300. Okay, that one's still in my interval. What if I take 240 and add 180? Can I find another one? Let's see, what's that going to give me? Oh, I'm going to go too big for this one. 240 plus 180. That's going to give me 420. That's where we cut it off. So it's these answers is what I would have to box in. Now I realize that I haven't done any like tangent ones or anything yet. So let me just go ahead and run through a tangent one just so you can see it. So let's do one where you have to solve a little bit actually. Let's see. I gotta make something up. So we'll do three. Sorry. Y'all know I'm just, when I try to make one up, it always takes me a second. Let's do alpha over 2. Let's do minus square root 3 equals 0. So sometimes we got to do a little bit of solving in there. You can choose what you want to do first. If you want to maybe get the tangent alone first, or if you want to replace first. I like to just replace first because it's just something that I noticed that I need to do. So I'm going to let alpha over 2 equal x. That way I can just get rid of it for a second. So I get 3 tangent x minus root 3 equals 0. Solving this, I get tangent x equals root 3 over 3. Now when I go to my table, just writing that out. Tangent is sine over cosine, so in this case it'll be 1 over root 3, 1, and root 3. Root 3 over 3 is the same as 1 over root 3. So be careful whenever you maybe see them in there. If you're used to seeing them rationalized or unrationalized, you may see the other version sometimes. So be very careful about that. So for this one, we would go ahead and we would get x equals My reference here is 30, and tangent is going to be positive in quadrant 1 and quadrant 3. Now remember, for tangent, you actually only need one of the answers. So this one's going to be 30 plus 180 degrees K. You can split them up and write out both the answers in both different quadrants. But if you remember in 4.2, because tangent has a period of 180, you actually don't need to write out both answers, as long as you just use 180K instead of 360 for tangent specifically. I'll go ahead and plug back in my alpha over 2. So I multiply by 2. So this will give me alpha equals 60 plus 360K. And that's it. If you had written them out separately, let's just kind of see what we would have gotten. So 30 degrees plus 360K. And then if you had done quadrant 3 by itself, so if you had said, let's see, what would that have been? That would have been 210 plus 360K. You'd have multiplied these by 2. So this would have been 60 plus 720K. And 420 plus 720K. So this is one way to do it. You'll notice that with this answer, if you just add 360 to 60, you get the 420 answer. So that's why the tangent, you can just write it a bit more condensed, and it's technically more correct because it's more simplified. I also warned you in 4.2 about maybe having some questions that require you to use a calculator while you're doing the homework. Like maybe, you can't get to the answer as easily as we are. Like maybe it's not in the table or something like that. I just want to maybe show you a question like that. So let me go ahead and pull one up just from the homework to see if I can get something good. A lot of them just make you use the the normal ones that we always see, like 30, 45, 60. But here's one that doesn't. So let's do C. Let's do, this one is sine. I'm just taking this one from the homework. Sine 3 alpha is equal to 0.3. So here's how I would do this one. This, I would do the same thing we've done before. Let it be x. Then I would get sine x equals 0.3. There is nowhere that we know of in our table or in our little unit circle that sine is equal to 0.3. So I have to use the inverse function for this one. Again, I don't usually like to use the inverse function because I like to structure this class as no calculator as much as possible, but sometimes it can be helpful. If it's positive, that means we're looking at quadrant 1 and quadrant 2 for sine. So the quadrant 1 answer, let's see what we get. We'll get x equals sine inverse of 0.3. I'm going to plug that into my calculator. and I'm going to get degrees for this one. And I'll just do one decimal place. It says 17.5. To get the quadrant 2 answer, I would need to do 180 minus that. And you can see that if you look at the general solution, or we can just kind of think about it. So 180 minus 17.5 is 162.5. And again, I picked 1 and 2 because it was a positive 0.3, so I knew it had to be where sign is positive. Don't forget to add your 360K to these. We also need to replace back in my 3 alpha. For this one, I'm going to divide by 3. So let's see what I get. 17.5 divided by 3 gives me 5.8. 360 divided by 3 is going to give me 120. 162.5 divided by 3 gives me 54.2. And then that would be 120K. So this would be my answer. Now I was looking at a homework problem, so I'm going to go ahead and type this one in to make sure that it's right. Let's hope for the best. The only thing I kind of worry about is that maybe there could be a rounding error with these. But it told me I was correct, so good news. Sometimes I do get a little worried about like rounding and stuff like that. And there's one more type of problem I want to show you in this section. And I do want to show you where sometimes maybe using an identity could be helpful. So let's see, what example are we on? 6. So this one says solve, says sine squared x plus sine 2x plus cosine squared x equals 0 for x in the interval 0 to 2 pi. So this one, we actually will use an identity to help us. And the reason we can see that maybe we should use an identity is if you notice that you have multiple different trig functions, like you've got sine and we've got cosine, that probably means we need an identity. Also, sometimes if maybe we saw like 2 signs, but they have different insides of the parentheses, that would be another time that actually using an identity would be helpful. So in all the problems we've done up to this point, it's just been one trig function. Maybe it has a weird parentheses, but it's one trig function. You should not be using any kind of identity to help you with that one. This one, we will need one, and it's because I'm seeing multiple trig functions. So if I look through this, I'm wondering if maybe you can see an identity that kind of pops out to you. If not, I'll tell you what it should be. Sine squared, cosine squared. So we have this identity that says that sine squared x plus cosine squared x is equal to 1. So right now I'm seeing that identity in this problem. So what I can do is just go ahead and replace it with 1. So for this one, I'm going to get sine 2x, and then instead of writing sine squared plus cosine squared, I'm going to write plus 1. And then I still have the equal 0. So I used an identity to get rid of the sine squared cosine squared because I know that adding those together just equals 1. So I made a replacement. Now I like to treat this like any other problem that we've done before. It's just sometimes maybe you might need an identity in the beginning, but really the only time you should really be needing one is if you have like multiple trig functions. That's usually the reason. So I'm going to let 2x equal, I just come up with any letter. Let's do alpha for this one. So I get sine alpha plus 1 equals 0. So sine alpha equals -1. Now -1 doesn't appear on our table, however it does appear with the quadrantal angles. Remember that sine corresponds to the y coordinate, so it's happening down here, which would be at 3 pi over 2. I'm picking radians because my interval here is in radians. So I get that alpha is equal to 3 pi over 2 plus 2 pi k. But I don't want alpha, I want 2x. So I'm going to replace that back in. So 2x equals 3 pi over 2 plus 2 pi k. If I divide by 2, remember that dividing by 2 is the same as multiplying by a half. So this will give me 3 pi over 4 plus pi k. And if it said for all values of x, I'd be done. I'd just box this in and we'd be, finished with the problem. But it wants it between a certain interval, so I need to check if I can actually add this pi to my answer. So 3 pi over 4 is definitely an answer. That's for sure between 0 and 2 pi. If it helps, maybe it would be nice to write it as 0 and 2 pi can be written as 8 pi over 4, making that fraction bigger numbers, scaling it. So basically, as long as my numerator is smaller than 8, I'm within the interval. So let's see if we do 3 pi over 4 plus pi. Will I get another answer? So this would be 3 pi over 4 plus pi can be written as 4 pi over 4, which would be 7 pi over 4. That is smaller than 8 pi over 4, so it is an answer. So these are going to be my answers for this question. Now, I don't believe using identities comes up on the homework in 4.3 currently, but it does come up in 4.4. So it's a nice time to just maybe introduce it to you and let you know that, like, when to be checking if maybe you should use an identity. Because a lot of students will try to use them for problems like these, part B of this one, this tangent one, because they just see something that looks similar to that on the identity sheet, so they try to use it. But it usually leaves them stuck because sometimes it's just not very helpful. If you are looking at one trig function and then just like a bunch of numbers, definitely don't need to be using an identity. You want to maybe use one if you're seeing multiple trig functions, maybe that have different parentheses, maybe have the same parentheses, maybe it's like a different trig function as in sine or cosine different, something like that. So we'll go through some problems in 4.4 of like more times to use identities. But for now, that will be it for 4.3. I hope you're having a good day. I hope these sections are going well for you. If not, remember that I'm always available to answer questions. As I'm making this video, my other class that I was teaching actually finished. If you're watching this video in like on Tuesday, July 8th, 2025. So I do have some freed up time. So I can, maybe focus on your class a little bit more. So yeah, just let me know if you're needing anything. I would love to be here for you.